Hello students, welcome to my YouTube channel and welcome to the topic of vector. In this particular video session, just we are going to discuss about the vector product, or you can say that cross product. In the previous video session, just we have discussed about the scalar product or dot product, and we have solved some of the problems based upon scalar product and dot product, or you can say that dot product. So let us go through the vector product or cross product. So let A vector and B vector be two non-zero, non-parallel vectors. Let theta be the angle between them. That means theta is the angle between A vector and B vector, such that theta lies in between 0 and phi. The vector product of A vector and B vector is defined as A vector cross B vector is defined as magnitude of A vector multiplied with the magnitude of B vector multiplied with the sin theta with n cap, where n cap is a unit vector perpendicular to both A vector and B vector, such that A vector, B vector and n cap form a right-handed system, and all of you know that what is right-handed system. So here the result is a vector quantity. In the result of a scalar product, we are getting a scalar quantity, but in the case of a vector product or a cross product, we are getting a vector quantity, because these terms are scalar. Magnitude of A vector multiplied with the magnitude of B vector multiplied with the sin theta, this will be a scalar quantity, but with n cap it will be a vector quantity. So it is all about the definition of vector product, cross product. So let us discuss about some of the rules based upon vector product. Now let us discuss about some of the important points based upon the vector product or cross product. So here it is the first point. If one of A vector or B vector or both is zero vector, then theta is not defined here. And theta is not defined means theta zero vector has no direction. If it has no direction, that means n cap is not defined. So in this case, the vector product of A vector and B vector is always zero vector. And the second point, if A vector and B vector are collinear, that means it has two cases. If theta is equal to 0 or theta is equal to pi, then the direction of n cap is also not defined, is not well defined. In this case also, we have to get the result zero vector as the vector product of A vector and B vector. Then in the case of note 3, A vector cross B vector is read as A vector cross B vector. Since we are putting the cross between A vector and B vector, that is why it is called as cross product. As the resulting quantity is a vector, so it is also known as the vector product. So the first two notes are very much important. It is only for the notation symbol, and in the note number 1 it is said that if one of A vector or B vector or both are zero vector, that means theta is not defined here. That means the angle between A vector and B vector is not defined here. That means zero vector has no direction, and so n cap is not defined. In the second note, if A vector and B vector are collinear, that means it has two cases. The first one is theta, either it is 0 or it is phi. Then the direction of n cap is not well defined. Either it will be 0 or it will be pi. So it is why it is not well defined. That means if the direction is not well defined, then in this case also A vector cross B vector is equal to 0 vector. Then let us go through the note number 4 and 5. Now let us get through the note number 4. It is a part of note number 1. If A vector is equal to 0 vector or B vector is equal to 0 vector, then the vector product in between A vector and B vector is always 0 vector, and we have already discussed it in the note number 1. Then let us go through the note number 5. And here we are trying to find out the result in which we are getting into the vector product of a vector with itself. That means let us take an vector A vector, then A vector product with itself. So it will be magnitude of A vector multiplied with magnitude of A vector into sine. In place of theta, we have to put 0, because the angle between a vector with itself is always 0 with n cap. But we know that sine 0 is always 0. So the total term here will be equal to 0 with n cap direction. As it has a direction, so it will be converted into 0 vector. So it is the result. That means we are getting here the vector product in between A vector with itself is always zero vector. Now let us discuss about the angle between two vectors. Let theta be the angle between a vector and b vector. From the vector product or cross product, we know that a vector cross b vector is defined as ab sin theta n cap. In place of magnitude of a vector, we have written a. In place of magnitude of b vector, we can write b. So magnitude of vector product of a vector and b vector, that means magnitude of a vector cross b vector is equal to ab sin theta, because magnitude of n cap is always 1 because it is an unit vector. So sin theta will be magnitude of a vector cross vector divided by AB. But in place of AB, we can write down magnitude of a vector. In place of B, we can write down magnitude of B vector. In place of A, we can write down magnitude of A vector. In place of B, we can write down magnitude of B vector. So theta will be sin inverse magnitude of a vector cross vector divided by magnitude of A vector multiplied with magnitude of B vector. So this is the formula which is used to define the angle between any two given vectors. Now let us discuss about the unit vector perpendicular to two given vectors. A unit vector n cap perpendicular to each one of a vector and b vector is given by n cap is the vector product of a vector and b vector, that means a vector cross b vector whole divided by magnitude of a vector cross b vector. So this is the formula is used to define the unit vector perpendicular to the two given vectors a vector and v vector. Now let us discuss about some of the properties based upon vector product or cross products. The first one is vector product is not commutative, and the result is here a vector cross b vector is equal to minus b vector cross a vector. Then the second one is, if a vector b vector are two vectors and n is a scalar, then a vector product with b vector is equal to n multiplied with the vector product of a vector and b vector. Then that is equal to a vector product with n multiple of a b vector. Then the third one, if a vector b vector are two vectors and n are two scalars, then the vector product in between n multiple of a vector and n multiple of a v vector, and the results are here, and you have to remember this. Then the fourth one is, let a vector, b vector, c vector be any three vectors, then these two results are very much important in case of problem. A vector product with the sum of a v vector plus and c vector, and the second one is the sum of a v vector and c vector and its cross product or vector product with a vector, and the results are here, and you have to remember all these properties. Then let us go through another three properties are there, and we have to discuss about that. Now discuss about some of the rest of the properties 5, 6 and 7 for any three vectors a vector, b vector, c vector. Here it is the result a vector product with the subtraction of two vectors b vector and c vector, and the result is here. And in the sixth one, two non-zero vectors a vector and b vector are parallel or collinear, both of the cases if and only if the vector product of the two given vectors, that means a vector cross b vector is equal to zero vector. And the seventh one is a vector cross b vector is equal to zero vector. It is given to you. That means we can find out a vector is equal to zero vector, or v vector is equal to zero vector, or a vector is parallel to b vector, or a vector and b vector are collinear. So these are the three options we have. We can get from the value of, or from this given data, a vector product with b vector is equal to zero vector. We can have three results. Now let us discuss about the vector product of an orthonormal vector triad. We know that the three unit vectors I cap, j cap, k cap are mutually perpendicular to each other. So it is given that for mutually perpendicular unit vectors I cap, j cap, k cap, we have I cap cross I cap is 0, j cap cross j cap is 0 vector, k cap cross k cap is 0 vector, because we have already discussed the vector product of any a vector with itself is always 0 vector. So by assuming this result, we have this first point. And in the second point, the vector product of I cap with j cap is k cap, but in the reverse direction, the vector product of j cap with I cap, it is minus k cap. And similarly, rest of the results are here. Now let us discuss about the most important vector product in terms of components. Because the two given vectors are represented in terms of components, that means along with the unit vectors and along with the three axes. Let A vector is equal to A1 I cap plus A2 j cap plus A3 k cap, and B vector is represented by B1 I cap plus B2 j cap plus B3 k cap. Now here it is the time to find out the very important result, the vector product of A vector and B vector, which is represented by, or which is represented in terms of determinants, and it is represented by the determinant of I cap, j cap, k cap, the three unit vectors, and then the coefficients of the unit vectors of A vector, A1, A2, A3, and then the coefficients of the unit vector B1, B2, B3 of the second vector. And it is the most important formula for the problem section. Now let us discuss about some of the basic fundamentals of the vector topic, and later on we have to discuss some of the basic problems based upon it. Now at last discuss about some of the basic 5 important formulas which we are going to use in the problem section. The first one is the area of a parallelogram with adjacent sides A vector and B vector is given by only the vector of A vector and B vector. The second one is the area of a triangle with adjacent sides A vector and B vector is given by half of magnitude of A vector product with B vector. Then the area of the triangle ABC is given by half of the magnitude of AB vector cross AC vector, or half of magnitude of BC vector with BA vector, or half of magnitude of CB vector product with CA vector. The area of a parallelogram with diagonals A vector and B vector. Here it was given the adjacent sides A vector and B vector, and here it is given the diagonals of a parallelogram A vector and B vector. It is given by, the area is given by half of magnitude of A vector cross B vector. At last, the fifth one, the area of a plane quadrilateral ABCD is given by half of magnitude of vector product of SC vector and BD vector, where SC and BD are the two diagonals of the quadrilateral ABCD. So in this particular session, just we have discussed about the fundamentals, the formulas, the basic concepts, and the properties of the topic vector product, or you can say that cross product. In the next video session, just we are going to discuss about some of the problems, fundamental problems, important problems, and highly based problems based upon the vector product or cross product. Till then, thank you.